Hello everyone. Today we are going to continue with graph transformations. As I mentioned last time, we discussed the transformation of polynomial functions. Today we are going to introduce more functions. I already taped a similar session, but the sound was terrible. So what I'm doing is that instead of redrawing stuff, I'm going to use what I already have, so to save time, so to speak. So here's basically what I started showing. I said we have several parent functions, as we call them, remember? So the first one is the absolute value graph. It's the same as x equals y, but y cannot be negative because I have an absolute value for f of x. So this one is like it's projected on the x-axis. So you get like a V shape. The square root function grows slower than the square, of course, right? Square root grows very slow. And again, you can't have the square root of a negative x. So once x is below 0, you don't have anything because that's imaginary number. F of x is the reciprocal of x, 1 over x. You get this shape. Notice that this is similar to what we said before. X here is -1. If you consider it as a polynomial, it's -1, meaning it's odd. So if the right-hand side goes to infinity, the left-hand side would go to -infinity. They are opposite. But when you say 1 over x squared, this is x to the -2, and it's even, and it's positive. So if the right-hand side goes up, also the left-hand side go up. But the reason they go near the 0, not near infinity, is that this is the reciprocal. And you know 1 over infinity is 0, and 1 over 0 is undefined or infinite. And the last two I showed, and there are others, is the exponential function, where the base here a, if it's positive, it goes up to infinity. If it's negative, it goes the other way around. Okay, natural log of base a. Again, you know that log 0 is undefined, it's -infinity. That's why this one is asymptotic to the y-axis and is going to infinity. Log 1, meaning if this is a, log a of a is 1. So it passes, and log 1 is 0. So it passes through 0.1 and 0, and then it passes through the base and 1, the base square and 2, and so on and so forth. Also, it grows very slowly. A to the x on the other side, if x is 0, any base to the power of 0 is 1. So, first of all, if x is 0, you get 1. F of x would be 1 because a to the 0 equals 1. And 1 and a, notice it's the exact opposite, because these are, what do we call those? Inverse functions. And inverse functions, you have to think, if you think this is y is a function of x, where if you solve this as x is a function of y, you will get the same graph exactly. And again, basically, these are the 6 I showed last time. Maybe today we'll do a couple of examples. So let me start with maybe an absolute value graph. Let's say, so graph transformation, and this is the second session, graph transformations. Suppose the example we have here is we want to describe and graph the following curve. Let's say y equals 2 absolute value of 3x minus 1 plus 4. So we know for sure that the parent function here is what we already drew, f of x or y equals absolute value of x. So this is the parent function. Now, if we follow the same logic we did before, I just need the absolute value on the right-hand side. So I have to subtract 4 from both sides. And that gives me y minus 4 equals 2 times this absolute value of 3x minus 1. And then I'm going to divide both sides by 2. And end up having, remember I put them between parentheses, I don't need to use parentheses with the absolute value, but this is y minus 4 over 2 equals absolute value of 3x minus 1. So what are the transformations that we apply to the parent function? You do it backwards. You say, okay, how do I get the x back, or the 3x minus 1 back to x? The first algebraic operation is that you add 1, right? Adding 1 to the x, meaning moving x to the right 1 unit. So I will get 3x, divide by 3, dividing by 3, meaning shrink x. Notice that usually the word used or the, for the graph transformation when you multiply or divide is called dilation. But I don't like to use the word dilation because it gives the impression that we are like stretching something. But if the dilation factor is less than 1, you are shrinking. So I use the term stretch and shrink instead. Okay, I mean, yes, you can use dilation. You can say dilate by a factor of 1/2, which is a little confusing. Oh, dilate by 1/2, so it's shrinking. So I prefer to say shrink or stretch. Stretch by a factor of 3. And I'm done with the x. So I'm going to move this graph 1 to the right and make it more like narrower. Then I move to the y. Again, you multiply by 2, and that's stretching y by a factor of 2. Notice that I'm shrinking x and stretching y, which is the same as shrinking x. And I will show you that maybe later. Now, after that, you will add 4, adding 4 to the y, meaning move 4 units up. It's that simple. So you can explain exactly what happens in detail very easily. Now, let's look at the graph. X and y for the parent function, it's the same. X equals y, except if x is negative. So if I say -3, it's 3. -2, it's 2. -1, it's 1. 0, 0, 1, 1, 2, 2, 3, 3, and so on and so forth. So very simple. Now let's move to our function, my x and y. What did I do to the x? I added 1 and then divided by 3. Add 1, it's -2, -2/3. Add 1, it's -1, -1/3. Add 1, it's 0, 0. Add 1, it's 1/3. Add 1, it's 2/3. Add 1, it's 1. Add 1 is 4/3. That's it. Now, what happens to the y? I'm gonna multiply the y by 2 and then add 4. Multiply by 2 is 6, plus 4 is 10. By 2 is 4, plus 2 plus 4 is 8. 2, and you can see that it decreases by 2. By 4 is 0, plus by 2 is 0, plus 4 is 4. By 2 is 2. By 2 is 4. By 2 is 6. And it would decrease by 2 until it reaches this point, which is this what 0 would become, and then go up. Again, let's do like we always do. Plot these two functions. Oops. So the first one is y equals absolute value. So I have to go to math and take I think here is the absolute value of x, and then I go down to 2 math absolute value of 3x minus 1, and then go out and do plus 4. I'm going to change the window. My smallest x is -3, so I can start from -5. The highest is 3, so that's fine. But when I go to the y, of course, I will change that. So the lowest y is 0 and the highest is 12. So I can say 0 to 20, for example. That's my first graph. You see the second one? It got narrow, shrink, moved it. We moved 1 to the right. You see the vertex here, instead of being at 0, it moved slightly, and then we moved it up 4. Now, if you want to check, you can go first to the table to check the integer values. So here is 0, 0, 0, 6. So let's go to 0, 0, 0, 6. We also have 1, 1, 1, and 1, 10. So 1, 1, oops. Yeah, we said this increased by 2, and I increased it by 4. I'm sorry. See here, you can catch any error that happens. Yeah, when you do 2, you multiply it by 2, you get 4, and then you add 4, you get 8. So I can do math. Okay, so, and here we caught this error, 1, 1, 1, 8. 1, 1, 1, 8. If you want a specific value, let's say what is -1/3. So I would go to the calculator and say find the value when x is 1. Oh, I'm sorry, it's -1/3. It gives me the first graph, which is +1/3. I need the second one, and the second one is 8. Yes, it's 8. So that's for the graph of an absolute value. Let's try something else. We can do 1/x, or oh, that was something other than that. Suppose, and this is for you to see why, if I have y equals the absolute value of -x, and you say the absolute value of -x is the same as the absolute value of x, right? Because the absolute value of -4 is +4. So I should get the same graph. How is that possible if I have transformation? Well, now you see that in order to make that an x, you have to change the sign. And changing the sign is reflecting, changing the sign of x is reflecting over the y. What would happen if I turn this like that? Nothing happens. See that? So if I reflect about the y, it's the same as I leave it where it is. Same thing happens if I have like even functions. Like if I say what is y equals negative x plus 4 quantity square. Some people will tell you, okay, first of all, I have to subtract 4 and then rotate about the y. But I can tell you it's the same as x minus 4. You don't need to do 2 steps. You simply add 4. Do you see that these two are the same? If you don't, you have to learn this fact. X minus y square is the same as y minus x square. And this happens for even functions. Like cosine -x is the same as cosine x because it's negative. So notice if you expand those, you get x square, -x times -x is x square, minus twice xy plus y square. It's the same function. It's exactly the same. So once you rotate or you take a even function and reflect it over the y, it stays the same function. Okay? So that's something just I wanted to mention on the fly. We don't have an example like that. Let's take another example. So if we say, what about this equation? Suppose I said y equals negative 2e to the negative x plus 4. I see that the parent function is y equals e to the x. E to the x is a function like that that passes through 0.01, 1e, and so on and so forth. So let's look at what happened. First of all, I want it to look like that. So only e to the something stays on the left. I'm going to subtract 4 from both sides, and I get y minus 4 equals e to the negative x. And then, negative 2 e. And then I'm going to divide by negative 2 both sides. And that would give me negative, notice we prefer to leave the negative out, y minus 4 over 2 equals e to the negative x. I know how to construct the table for y equals e to the x. If x is negative 1, this is 1 over e. If x is 0, this is 1. If x is if x is 1, this is e. If x is 2, this is e squared. So what did we do here? I'm going to change the sign of x, meaning mathematically change sign. Description reflect over y. And what do I do here? I'm gonna y negative, change sign also, meaning reflect over x. Okay, I'm sorry, this is reflect over y. Yeah, we wrote that, and this is reflect over the x-axis. Then I'm gonna multiply by 2, right? That's the math. The explanation is stretch by a factor of 2. And then I'm gonna add 4 plus 4, meaning move up 4 units. So let's now construct the xy for my function. For the x, I'm going to stretch by 2, so the negative 1 becomes negative 2, meaning multiply it by 2. And then go, that's it, stretch by 2. This was for this guy, I'm sorry. And we have to reflect over the x, so the negative 1 becomes 1, and then stretch by 2. So I'm confusing. This is also for the y. I wrote it stretch by 2. Terribly sorry. Okay, so for the x, we only change the sign, right? We only change the sign, meaning we reflected over the y. I should have drawn the line here. These belong to y, these belong to x, but I got myself confused. So just changing the sign, meaning the negative 1 becomes 1, 0, negative 1, negative 2. That's how simple it is. I made it hard. On the right hand side, you're going to multiply by 2, so this is 2 over e. First of all, you change the sign, so it's negative 1 over e. Multiply by 2, it's negative 2 over e. Add 4, so 4 minus 2 over e. This one, change the sign, negative 1. Multiply by 2, negative 2. Add 4, it's positive 2. E, change the sign, negative e. Multiply by 2, negative 2e. 4 minus 2e. Change the sign, negative e squared times 2, negative 2e squared, 4 minus 2e squared. And again, guys, I'm so sorry about the confusion here. This thing is the y transformation, this part is the x. I used like 2 columns, so I got myself confused. I thought this is y and this is x. Okay, let's look. Hopefully, let's clear those. The first equation is e to the x. The second equation, we said it's negative 2 e to the negative x plus 4. So here is e to the x. Oh, the other function. We rotated about the x, we rotated about the y. Wait a second. Does that? Okay, let me check the table. 1 is, no, 0 is 1, 0 is 2. 1 is, should be, 1 is e, yes. And 1 here is that probably correct, but here we cannot have integer values. Let me see if, because the y would always be something like that. So let's check, for example, negative 1, is that 4 minus 2e? Negative 1.4 minus, oops, 4 minus 2e. Negative 1.437, yes. So if we say x is negative 1, yeah, negative 1.437. If we try 0, we already did that. How about negative 2? So let me do 4 minus 2e squared. It's negative 10.778. Now let's see if we get this number, negative 10.778. Now if I go to calc and I say, oops, take the value of x equals negative 2, that's the first function, the parent function, that's the other, negative 10.778. So it's correct. And now if they ask you what happened to the parent graph, you say, or the parent curve, we reflected it over the y, we also reflected it over the x, then we stretched the the y by a factor of 2, and we moved, or we translated the whole graph 4 units up. Very simple. Again, I don't know about this. I hope it didn't confuse you, but I apologize for the second time. I think once you understand what we did here, it should be clear what we did. The next session I will go over trig functions and the transformations of trig functions. And again, thanks for your time. If you have any comments, please let me know, and I'll see you soon.